5-minute break for everybody. So maybe we can start with Tatiana, who had a question for Jacki, if she's around and wants to come on and ask that question.
Oh yeah, it was kind of a detailed question. Can you hear me?
Yep, we can hear you just fine.
It was about the comparison that Jacki was making between the chlorophyll, the comparison that didn't do that well between the satellite and the flow chlorophyll. And I was just wondering about how biased the satellite data is to the surface. I mean, the idea is that it's making a single measure that applies to the entire optical depth, but it's probably very influenced by the surface. I actually don't know the answer to that, but I'm guessing. And then floats, Argo floats don't measure the surface very well. So are they even measuring the same thing?
Can you hear me?
Yes.
Yeah. Okay, good. No, that's a great question, and kind of actually one of the next steps that I want to look into, because that you're 100% correct. So the floats, kind of sadly, but it's the best we can do, they don't actually surface. So you're missing that kind of critical upper water column area. They might get to about 8-meter depth surfacing, or 5 meters. If they did surface, there might be a lot of biofouling. You might there's active pumps on them. They might pump in air, all these messy things. So we don't do it. So what I've done in this to get a full estimate of integrated net primary production throughout the entire water column is I just took that surface most estimate and assumed it was the same throughout the rest. So that may be biasing our float results high. So kind of the next step is I'd like to pull in some discrete observations, maybe some more stuff from line P, and look at how variable just that upper water column is to get a better float estimate, and also compare more apples to apples with what the satellite's seeing. So,
and also, how do you deal with quenching? Because I noticed that I was the one who pulled the data for Angelica to plot it up, and I was thinking about the fact that they come up in night and in day, and it doesn't seem there's no control over that, right? So how do you deal with that? Because the float not only is not measuring the surface very well, but of course, if it comes up during the day, those surface fluorescence data are probably suspect.
Yeah, and you can see the differences from day to night profiles. So there's a standard approach by Jing et al. And I'm not sure where you got the float data from, but if you download it directly from a website called FloatViz, it's offered from the Johnson Group at Mbari. This data you can download as QC'd data. And that's one of the QC processes that goes into this fluorescence measurement, is taking into account the effect of non-photochemical quenching and correcting for that day versus night profiles.
Okay.
So good point. You brought that up because it definitely makes a difference.
Okay, yeah, thanks.
Awesome. And then Clarissa had a few questions for Angelica, if you want to go down that line, Clarissa.
Yeah, I think I was jumping the gun on some. We've gotten some answered throughout the talk, but so maybe I'll just jump to the last one where, well, actually one kind of pertained to Jacki, which was that I wondered if anyone was looking at phytoplankton functional algorithms and looking at that in conjunction with your work, and if there'd be anything to learn from that. For the
so it looks like, yeah, in regards to the exports team, which was mentioned, absolutely. The exports team is huge in a lot of people, and they're very optically focused. And then for this work specifically, we are looking at taking kind of a next step and using an approach described by Briggs et al. In a 2020 paper, where he took backscatter data, which is what we're using, and then working with my collaborator, Mariana Biff, she has kind of adapted this approach to change the way that he uses his baseline correction for backscatter, which is the QC approach we're using for backscatter. And then in Briggs, they're taking that backscatter measurement and dividing it into small and large particles. So we'd like to kind of do the same and look at that in context of our NPP results and NCP, which is exciting. And will happen soon.
Yeah, we are also working with trying to produce some algorithms to use satellite data to determine phytoplankton composition. I'm working with my Myceta Costa and her group, trying to see how we can do that using the pigment data that we have, hyper HPLC data, and try to see if we can come with a good algorithm to calculate those different groups. Actually, I just wanted to mention that I had no idea Jacki was going to give the presentation she gave, so it was great because I spent quite a bit of time trying to, find evidence that nitrate was consumed by phytoplankton. And just 2 days ago, I think it was maybe yesterday or the day before, that I was talking to Tatiana and I say, do you think there is any Argo data around there? And we found that. So I was quite excited to see that it was not just, one cruise that showed low nutrient concentration, but the Argo float showed the same, and that net primary production was quite high. Net community production is a bit different. So, but yeah, so it's quite exciting to see that the two observations that are completely independent were showing the same answer. Now, with respect,
yeah, go on.
Now, with respect to your question of iron, I think the most likely reason that iron was there is really a change in the remineralization, in the depth of remineralization, because those diatoms usually use the iron and they can sink below the pycnocline and really remove the iron for the outlier. But if the pycnocline is becoming so sharp that they are not, and they are still pretty small diatoms, then they could be remineralized in shallower depths. And then this iron that is being remineralized probably in the fall and winter get mixed up to the upper layer. So I think that's something that we will try to see. We have some measurements of iron that haven't been analyzed from the line P cruises, and we will try to see if we can see something. The problem is that it's very hard to measure iron, and also it's hard to think that if iron was, the iron flux was increased, it's hard to measure it because most likely the phytoplankton use it right away. So you wouldn't see it in the concentration. So it's a bit of egg chicken question there. I mean, if you don't see iron, it's because it was used right away or because it wasn't more abundant.
Well, it looks like an anonymous Good Samaritan has answered the stable isotope question, I guess, which was kind of the follow-on to that, at least that there is a chance to examine that further, the remineralization.
Yeah,
question.
I have to check. It's not one of the measurements we do routinely in the line P, but there are many collaborators in the line P program, so I have to see if anyone was doing those measurements in 2019. That's a good question. I should check that.
Great. And then the last little point here, maybe Andrew's got two questions. I think one was about parsing out new versus recycled production. And then he just posted another one here about higher temperatures raising metabolic rates. Andrew, if you want to jump on, I think both Angelica and Jacki might have some thoughts, and then we can take a break after that.
Yeah, that's it. You summed it up. So yeah, I'd love to hear their thoughts on that.
Yeah, I think for sure. I mean, I think that yes, primary production is being stimulated by the temperature. We have carried several modeling activities in the last 10, 20 years, and we have seen that temperature for sure is an important limiting factor to phytoplankton growth. So temperature not only could be stimulating the growth of phytoplankton, but also the remineralization of particles in the upper layer. So yeah, those two things are also a factor. But the reason I didn't really focus much on that is because 2014 and 15, we are also warm, but we didn't see this depletion of nitrate.
I like Al's question too. Sorry, go on.
I was just going to say for the question of recycling versus new production, I think, I mean, I guess we're not sure right now, but Mari's NCP results, which were based on nitrate, that reduction she saw, Biff, might be due to recycling. However, we're also seeing right now the same thing in the carbon and oxygen budgets. So TBD to that question.
Yeah, one thing I would like to mention is that we have observation from several programs that show that at Ocean Station Papan and in the high neutral chlorophyll region of the North Pacific, most of the production is remineralized. So most of the production comes from ammonia and it's no new production. In general, new production is about 30% of the total production. So that's something to keep in mind. We are talking now about difference in that sort of 30% that is usually there.
So sorry, can I follow up then? So do you think it's possible then that the recycled might be staying similar and that it's the new production that was changing?
Yeah, for sure, new production was changing. But what I'm saying is that it was a remineralization of the iron. Remineralization of nitrate happened all the time. But usually the particles or the phytoplankton that takes most of the iron is the diatoms. And they are the ones sinking below the main pycnocline. In these warm years, I think that the diatoms are not sinking and they are remineralizing the iron. And these are only maybe a 30%, 20-30% of the total phytoplankton biomass. But it's that change in this iron-rich phytoplankton that is probably producing this stimulation of new production. Because in June, new production was mostly, or phytoplankton was mostly due to haptophytes. So it's stimulating the growth of all phytoplanktons.
All right, thanks so much, everybody. It's been a great morning thus far. We're gonna take our first break. I know Howard wanted to talk about Argo floats. Maybe we can handle that in the chat just to make sure everybody gets a break to grab coffee, bio break, whatever folks need. So we'll come back at 10:35 Pacific. That's 7:35 if you're in Hawaii.